Everyone, we're doing another programming challenge. This one says, this problem was asked by Amazon. There's a staircase with n steps and you can climb 1 or 2 steps at a time. Given n, write a function that returns the number of unique ways you can climb the staircase. The order of the steps matter. For example, if n is 4, then there are 5 unique ways. Here they are. I guess the thing to note here is that these all sum up to 4, right? To the n that you're given. So this sums up to 4, this sums up to 4, and so on. Follow up. What if instead of being able to climb 1 or 2 steps at a time, you could climb any number from a set of positive integers x? For example, if x equals the set of 1, 3, 5, you could climb 1, 3, or 5 steps at a time. Generalize your function to take an x. I think this seems like a pretty straightforward problem. We're gonna skip straight to the follow-up because the follow-up is a perfect generalization of the original problem. Like, you know, if you can solve the follow-up, you can solve the original problem just by passing in the set of 1, 2 as your set as your x here. So we're gonna go straight for the follow-up, and so the general strategy is, okay, so you start with n, and you could probably do a recursive solution where you say, let's assume I start with 1, like I take 1 step here, like, you know, the first element of my array. So now there's 3 steps left to do, and then how many different ways are there of climbing 3 steps using this set of possible moves. So like in pseudocode, maybe you have your function here, and you have your set of possible steps and whatever n is, and it's something like, I'm not going to write out the full pseudocode, but because, you know, we're going to get to that when we write the actual code. But it's basically for each possible move in n, you're going to say, well, let's say, well, you got to do some search check where, like, make sure the move you're thinking of is smaller or equal to, I guess. And if it's not, you know, you gotta handle that case. And if it is, then you're like, okay, so I'm gonna do that first move, concat with all possible combinations of whatever this guy returns, which is the same set but n minus move, right? That's the basic, that's the pseudocode that we're gonna write. So because I think this is going to be a straightforward challenge, I'm going into hard mode here. So if you guys have seen my other videos, I have a wheel here where I usually weigh it so that the languages that I'm more familiar with appear more often, like Java. I'm pretty familiar with, and so every time a language I'm not familiar with, like say Dart appears once on the wheel I normally use, but Java will appear 5 times. So, and Kotlin is another language I'm familiar with, so that it appears 5 times, JavaScript and so on. So languages I'm more familiar with are weighed 5 times more heavily, basically. But this is the hard mode wheel where languages I'm familiar with have a weight of 0. So Java doesn't appear in here, JavaScript, Kotlin. I think Ruby also I took out. I don't remember exactly what I took out. But anyway, these are all languages that I'm not super familiar with. So I predict the majority of this video will be me looking up, like, what are the standard functions, what are the standard libraries available to me in these languages. So let's spin this, see what we get. Rust. Okay, we're going to do this in Rust. So I have my environment set up like this. I got SSH into my thing, and then we want to go to the Rust directory. Okay, so I'm going to copy hello.rust to, I guess I'll call it stairs.rust, and then we're going to open that file. So it's my program challenge. Where did I put it? I can't even remember. Dang, where did I... Oh, maybe I put it in e/program challenge. Yeah, there it is. Rust. Stairs. Okay, and how do we compile Rust programs? There's a README file here that explains that. Rust C, then that produces the executable. So Rust C stairs produces a stairs executable. Yep. So I can do Rust C stairs and then append stairs to it like this, and it should. Oh, I gotta say from the current directory. Yeah. So this compiles and runs the program. Okay. So here's what we have. And we want to write a function, I guess I'll call it stairs or something like that, which takes a set of moves and n, some value n. And I have no idea. Okay, so Rust is how do I declare a parameter in Rust? Let's declare a function. Functions in Rust. Okay, but I want to see function parameters. All right, so let's say this is an iter2 in tier 2-bit integer. Is there like uint or something like that? Rust data types. Tuples, okay, sure, but I just want to know, like, do you have unsigned ints in Rust? Yes, we do. So let's go with this usize maybe. Does usize what I think it is? Does that just mean like just give me any arbitrary unsigned integer? Dependent type readers. Yeah, it is. Okay. Set of moves. Okay, is there a set data structure built in? Tuple. Array maybe? Okay, but how do I declare a parameter of type array? Rust function taking array parameter. Like this, okay. And just to confirm that works, and also because I don't know how to print stuff in Rust. I don't even know how to do string concatenation. Rust string concat. It's just addition. Oh, there's a formatter here. Okay, that's actually what I want. I want to do formatting. I didn't know that was built in, so I was going to do concatenation myself. And then I'm just gonna invoke this guy, and then I guess I do an array literal like this maybe. Let's check if this works. Nothing here worked. Expected slice found array of 2 element. I don't know what that means. Doesn't have a size known at compile time. The size of value usize cannot be known at compile time. I may have gone way over my head by trying to do this in Rust. Rust function taking array. I forgot what passes CRA to this. That's not what taking effect. I don't want to vec. I want to write a function. Gosh darn it! Give me parameter. Maybe this guy will tell me how. Yeah, isn't this... Oh, but that's the question. This guy is saying Rust references denoted by are two kinds: immutable and mutable. In order to change the value, I don't want to change the value. Let's go with 32 for now. Let's make, oops, where's my text editor? Here we go. This guy doesn't implement display. Well, that's annoying. You can't print out an array in Rust. That's not display. Rust display array. How to print structs and arrays. That's, yes, that is exactly what I want to know. You want to implement the debug trait using derived debug. You can print it with that. What? No, I don't want to create my own struct. I just want to print out an array. Okay, it's saying I can do this. Maybe this is for a different trait. I don't know what that means exactly, but it sounds like expected this, found an array of T elements, consider borrow here. I don't know what borrowing means. I should probably find that out someday when I want to do Rust. More Rust about help. Convert the identifier to snake case. Set of moves. They wants it. Rust likes snake case. Okay. My understanding is borrowing is one of the core concepts in Rust for safe memory access, safe memory management. But okay, so we finally managed to get a little bit more advanced than Hello World here. But we managed to pass our values in, right? So now I got to say that this returns something. How do I do that? I'm guessing maybe. And actually, let's change this back to usize and see if this works. That also works. Okay. What is this going to return? It's going to return an array of something, I guess. Let's try returning this just to check if this works. And then I guess we'll print it out to confirm that we got the value. Do expected one of that. Okay, so that's not how you declare a function return result. So how do you declare a function return type? Rust function return type. Why does the Rust programming function not have what? Okay, so it's just a different notation. Sounds like I just gotta do this. Oh man, what the heck is going on here? Doesn't have a size known at compile time. Expected slice, found 3 elements. The return type of a function must have a statically known size. What? That sounds pretty crazy. It's saying I should read this thing. I gotta read a whole freaking book chapter. Oops. Is this on my clipboard now? Here we go. Oh man, what have I gotten myself into? This was a huge mistake. Maybe I don't want to do arrays because I guess that means I have to know the type of compile time. I want to do like some data structure where I don't necessarily know like a list, and I don't know how many elements are in the list I'm going to return. Common collections. Vector, that sounds good. That's probably what I want. Yeah, give me vector. I want to return a vector. And then like instantiate them like this, I guess. Alright, let's compile. Oops, not that one. Let's compile this thing. Okay, making progress here. But maybe I want a vector of vectors, right? Let's see if that works. 4, 5, 6. That works. Okay, cool. So how do I iterate over the array now? I'm gonna keep this tab open because this one looks useful. So new tab, Rust, iterate array. Here's my array. That's filter. Into iter. What the heck? This is getting way too involved for me. Is iterating over a vector easier? Do I just make everything a vector? Press iterate vector. For this and that, print that. Okay, let's try. For, do I need parentheses? This one, no, I just had without parentheses. For move, and move looks like it's a keyword because it turned red there. For a possible move in set of moves, line considering move this guy possible move. Does this work? Considering move 1, considering move 2. Yep, this is what I wanted to do. Okay. So what we're gonna do is, if possible move is less than or equal to n, then we're gonna do something. I'm gonna, is it, I saw the word let. Is that how you declare variables? It looks like it. Let ret val equal a new vector. Is that how? Actually, let's do some more experimentation here. Push this guy in. 4, 5, 6 in here, and then we return ret val. Let's see if this works. Unexpected token. Oh, I forgot a semicolon. Remove these parentheses, fine. Mismatch type. Expected use size, found use size. Consider using borrow here. Consider using borrow. Okay, I don't know why, but I'll do it because you told me to do it. Make this a binding mutable. Mute ret. Like this? Is this what it's telling me to do? Nice, that worked, okay. And just to make sure that's it work, I'll do this. And I should see some here, yep, okay. So, alright. After this video, I'm definitely gonna have to read up about this borrowing stuff, because I do not understand when I'm just like, cargo culting right now. You know, I'm doing the things it's telling me to do without really understanding why or what, you know, how anything works. But that's good. Like, this is pushing me to learn. Here's my opportunity to learn a bit of Rust after this video. Okay. So if I don't need this debugger output anymore. So if this possible move is less than n, so we can consider this. I guess, okay. So we gotta, I don't need this debugging output either anymore, I think. We have some n. If it's asking us if n is equal to 0, like if it's saying, oops, if it's saying you know how many different ways are there of going up 0 steps, well there's only one way, which is, or I guess there's 0 way is the way you put it. Like the solution is the empty set, right? Like you take 0 steps and you're already at the top. So that's our base case here. Otherwise, if we're not in our base case, we go through all our possible moves, and for each of them where it's less than the n, we say, okay, so all we have to do is we'll take possible move as our first step. That's our prefix to the solution, if you like, and then we have our suffixes, like everything we do after that move, and we just recursively call, what do I call it? I call it stairs. Same set of moves, and now we pass in n minus possible moves. And let me just check, does this even compile before I get too deep into this. Remove these okay, so for whatever reason, Rust doesn't like parentheses or after if submits. Consider using underscore suffixes. What? Oh, because it's unused? Yeah, well, I'm going to use in a moment. So if suffixes is empty, how do I do that? Does the vector data type have an is empty? Creating a vector that dropping reading elements of a vector. Iterating over the values using enum to store multiple. Oh, no, but I want to know size or length. Okay. Rust vector. Oops. Rust vector. Rust vector. Len. Returns the number of elements in the vector, also referred to as its length, and then is empty. Okay. So actually, I think I want to do two things here. If possible move is equal to n, and I don't know if I need that borrow thing or not, so we'll use it for now, and then we'll see. Then we have an else here, else if it's less than. I'm going to treat that as two separate things. So if my possible move is exactly the length of n, I'm going to say that one possible solution is to just take that single step, take this move that sets me to n right there. Otherwise, if it's less than, if it's greater than, that means we can't use that move because it would take us beyond n. So if it's not equal, the other case we care about is if it's less than, and this is where we do these possible move suffixes here. And then we check is empty, I guess. If there are no possible moves that you can do, like meaning if there's no way to get to the top of the stairs using the remaining moves that are available to you, then I guess we're gonna do nothing. We're not gonna. It means that this was a dead end. Like, so to show you what I mean by that, let's say our input array was 2 and 3, and then set of moves was 2 and 3, and n was 5. No, n was 4. That's a better example. Okay, and then I said, okay, well, what if I take 3 steps first? Well, there's only 1 step remaining, and I can't take that 1 step using any of the moves that are available to me, right? So taking 3 as your first step is a dead end. And so that's why I don't want to add anything to my return value, which is like the possible solutions I found. So yeah. So that's so if suffix is empty, that's bad. That means there was no possible way to reach n. But if it's not empty, if there's at least one value in it, then we want to create a new vector, I guess. A new sequence, like this is a sequence of vectors, and we want to create another sequence of vectors. For each of the vector in here, we want to create a new vector which has possum move as a prefix, and then add that into retval. So how do I do that? So now so here I want to iterate over the array, I guess. So I want to say for suffix in suffixes, and it's going to tell me to remove the parentheses because I'm still not used to this weird syntax of not putting parentheses here. So for each of these guys, can I prepend insert binary search? Wow, a lot of functions here. Okay, I don't think I care about any of this, so let's just use insert. Inserts an element at position index within the vector, shifting all elements after it to the right. Panics if index is greater than len, for example. Okay, let's see an example. Insert index element. I guess this is the self pointer. Assert equal, that might be useful. I'm gonna have to remember that when I do the testing later on. Index 1, so it's 0 index, so here's where the 4 got inserted. Okay. So I think, yeah, that's what I want. I want to suffix dot insert, and I don't know if the vector that I receive back is mutable here. So that's gonna be interesting to find out when I get these crazy compile errors that I don't understand. The index is gonna be 0, and the element I want to insert is this possum move. And now that I've mutated suffix, I want to put the suffix into here. Okay, and then I get rid of these guys. So let's see if this compiles and runs. Of course it went. Why would it? There's an if statement with parentheses somewhere here. Okay, don't put the parentheses. Fine. Expected because of this state. What? Mismatch type. Expected use size, but found ampersand use size. Retval push. What? What is it talking about? It's talking about this. Expected use size, found use size ampersand. Expected this type use size, but found this. Possum move. Oh man. For more information, try this. Yeah, okay, let's try that. Oops. Rust C explain E0308. This error occurs when the compiler is unable to infer the concrete type of error. It can occur for several cases, the most common of which is a mismatch expected in the actual type. For example, this is I am not a number. Okay, so how do I declare? Oh, I can do it like this. Vec use size, right? I'm saying this is that type. But possum move is not that type because it has this ampersand in here. So do I want to do a copy or something like that? Let me see. Expected type use size, found type ampersand use size. Rust expected type use size, found ampersand use size. The parameter to bubble sort must have this. List has type use size, so you must convert it. Okay. When you call supplement, you should pass the indices to you swap, not the values themselves. I feel like I have the reverse problem as what this person has. Yeah, I might have the inverse problem of this one. Okay, maybe I should read up on this ampersand operator. References and borrowing. Yes, this is what I want to know. This creates a reference, sure, but I want to dereference it now. Can I do that? Or do I just want to say these are references to usize? Is that the easier way to get out of this mess? Cannot borrow mutably. Cannot borrow mutably. Sure, explain it to me, Rest. Tell me what I should do if I want to borrow mutably. I'm assuming I need to make a copy of the guy for somehow. Can I borrow here? X is mutable, so we try to borrow it. To fix this, you need to make X mutable. I don't know if I can make X mutable. What I want to do is I want to make a copy, I think, of that vector. Is there a copy? Or a clone or something like that. Clone. I don't know what this means. But this sounds good. Let mutable suffix equals oh, I can just do this, I guess. So suffix clone. Is that how I do it? And then I mutate the suffix here, and then I do this. Oops, I don't want to explain. I want you to compile and run my program. Unexpected token, am I missing a semicolon? Yeah, I am. Okay. Oh, it worked. We solved it. Okay, that was a little bit anticlimactic. Let's make the output a little bit prettier, like make it match this a little bit. So found this many possible solutions, and then we're gonna do result.len, I think was the name of the method. Then we're gonna iterate over this, so we're gonna say for solution in result, I'm gonna print out that solution basically. Can I do this? Can I just print it out like this? Format argument must be a string literal, so I can't just print it out like that. This doesn't displace sorry, the trait doesn't, I don't know how to, I don't even know what this is. So I guess vector doesn't implement the trait display. So it wants me to do this debugging thing instead. What the heck? terminal got a little bit weirder. Found 5 possible solutions, 1, 1. Yep, let's see, does this match? There was 5 solutions here. Let me resize this a little bit. 2, 1, 1, 1, 2, 1, 1, 1, 2. Yeah, I found basically the same solutions. Just this guy and this guy were swapped, but otherwise it's the same solution. Actually, what that makes me think of is it faster to append to the end of a vector than to prepend to the front? It probably is, right? I don't know that is for sure, because maybe every time we do a vector, it has to do a full copy. There's a 0, 1 indexing amortized, 0, 1 push. Okay, so push is 0, 1 amortized. So let's do that, because insert, I guess, is ON, because it has to shift the indices of all the other guys. So rather than insert, let's just do a push. I think it's still going to have a correct solution, I think. And it's probably the exact same solution as this. 1, 2, 1, 1, 1, 2. Yeah, it is. Okay. And then what was the other thing they said? They said 1, 3, 5. So let's do 3, 5. What do we expect before we run it? Let's do a little prediction here. So 5 is never gonna get used because you can't take 5 steps on a 4-step stairway. It's gonna be like 1, 3, 3, 1, and then 1, 1, 1, 1. 3 solutions, something like that. Yeah. Okay. Runtime analysis. Let's see here. So I don't know much Rust. I'm assuming creating a vector is 01. If statements are 01, probably. This is so I have 2 variables. I'll call this N and I'll call this S. So this part is OS, right? Because we go through every element in this set at least once. Pushing is 01, it said, amortized, so that's fine. If statement's probably 01, if statement comparison is probably 01. Recursive call here is empty, is probably 01. Suffix depends on the number of possible moves here. Oh, so that might make it tricky to figure out. Yeah. Well, I'll come back to this. Clone might be ON, like linear time based on the length of the suffix. I'm assuming it would have to copy all of those over. This is 01, this is 01. Okay. So we have at least an S factor here, right? Because of this thing. So S times I'm going to take a step back and think of this in abstract terms without looking specifically at the code. So what's going on is we have S possible moves. So let's say we had, I'm going to make some comments here, so, some block comment here, so I have room to draw some ASCII art. Let's say we have 3 possible moves in our set of moves, right? So we'll call them A, B, and C. So what this algorithm does is it says, well, what happens if I do A first with N? So then on the next step I have an N minus A, and then I have 3 more moves, right, that I could do. And I keep doing this. Let's say I take A again. 2A, I guess I'll call it. 3 more moves here. B, C. And I keep doing this until I reach 0, right? In which case I'm done. And so in the worst case, I make like A would be 1 basically, and B would also be 1. Like the worst case is if I have a whole bunch of arrays like this. And so the idea is like I'm always going to make some minimal progress towards decreasing N, which maybe I should mention there's like edge cases here. set of move contains 0 set of moves contains duplicate elements, like if they're all 1 here. Do we want to dedupe this in any way? But putting that aside for now, assuming it's at least 1. Oh yeah, and then set of moves negative is the other interesting. No, it can't be negative because I use unsigned here. Okay. But anyway, so I'm always making some progress. So the slowest progress I would be doing is like 1 step at a time. And so basically you have, what is this, like OS, like, so this is S, this is another S, and this is S, so you're just multiplying S by itself n times, right? So this is like an exponential solution in the worst case. That's stepping back without actually looking internally at any of this. If we do look internally at any of this, so here's our S factor here. So this runs S times, and then it calls this, which run, you know, in each of those 1 S times, there's a recursive call where we do another S times, with a slightly smaller n. So yeah, that fits this analysis we see here. So runtime is S to the n. Is there a faster / better solution? Maybe with memoization. What do I mean by that? What do I mean by that? What I mean by that is it's I'll explain using a concrete example. So we'll use 1 and 2 again. So at the set move is 1 and 2, sorry, 1 and 2, and the n is 4. So say, okay, let's consider all moves where I take 1 step. So what I want to solve is, so I say like let my prefix be 1, and then I'm letting my suffix be 1, 2 with 3, right? And then we solve this in some way, and then I get the set here, and then I do this thing where I combine each suffix with this prefix. Except I flipped them around here because I did a push, but whatever. We're doing right to left instead of left to right. It's not a big deal. But so when I guess I need to do one more recursion case. So when computing this guy, I would recursively say, okay, let my prefix be 1 here, and then I want to compute with this, right? All possible suffixes here, which is going to do something. And then, so this is one recursion now, so maybe I'll indent it to say that this is like a recursive call as a result of doing this. Oh, I called set, but I meant stairs here. So let me be a bit more explicit here, because I feel like I'm hand waving too much and then it might be confusing. So I want to solve, like, this is my main function, right? Like, this is down here. I want to get the answer for this. Let me put this back to my resolution. Okay. So to solve this, I would first say, as part of my recursive call, is I would want to compute this. I say, okay, let me take one as my as the first step I take, and then I'll compute. I subtract 4 minus 1 to get 3 here, and then I say, okay, show me all other possible moves, and to do that recursively, I guess I'll do the notation like this. To that recursively, I'll say, okay, let me take 1 again, because that's one of my possible moves, and then subtract 1 from n to get 2, and then I'll get all possible suffixes here, and then this, this keeps recursing, and eventually this returns, and now I have the solution to this, which means then I have the solution to this. But this one here was only one of my 2 possible moves, right? The other possible move I could have done was take 2 steps. So then in my next, at this level of the recursion, I would say, okay, so let me now consider what happens if I make my prefix be 2. And so I would then call, let's suffix theirs with that 2 here, because there's 4 steps and I took 2 steps, so 4 minus 2 is 2. So I have to compute this, but here's the thing. So this call and this call are identical, right? So I could just redo all the calculations, and that's what gives me the OS to the N runtime. But alternatively, I could have cached this, right? And then I could have stored this somewhere, and then here I just do a lookup of the value. Do we want to try to do a memoized version of this? How much time I spent? I did 46 minutes. Okay, so let's try to do a memoized version. I don't know if I'll succeed because I don't know Rust basically. Is there a map? An iterative maps about, no, that's not what I want. Makes a new ref component board. I don't know what that means. Flat map? Nope. Hash map. That sounds good. A hash map implement with linear probing and Robin Hood bucket stealing. I don't know what that means. A lot of fancy words here, but what I want to check is the key idea, which is, do I... Yeah, this is what I think the data structure I'm looking for. I'm hoping it's O1 insert and retrieve. Does it say anywhere? Get. Returns a reference to this. They don't say that it's O1, but it probably is, right? Hash map. If it's a hash map, surely it must be O1. I'm skimming through this, but I don't see like big O notation anywhere here, so let's just assume that's O1 for now. Can I do global variables in Rust? Hashmap new. And it's mutable, yes. From what to what? From usize to fec usize. Let's compile this and see if this compiles. Expected item. Okay, let me real quick say press global variable. This sounds like what I want. Let's check if this compiles. Oh, I have to use the module. Yeah, I saw that out of the corner of my eyes, but I didn't do it for whatever reason. For some reason, I thought maybe if I don't do it, it'll work anyway. How silly of me. Calls and stack are limited to tuple structs and... What? Calls and statics are limited to tuple structs and tuple variants. Note, a limited form compile time function evaluation is available on nightly compile via constant function. That's not what I want though. Okay, so slightly crappier is I can just have the caller pass in the cache each time. this here as a comment because I'm probably going to reuse this in a moment. Dead code, right? Okay, so we never call stairs memo. I'm sort of cheating here. So I'm making a cache whose key is only n. Like I'm assuming that set of moves is constant here, and maybe I should make that more explicit in my my program. Let's see if this compiles. Refutable pattern, not covered. I don't know what that means, but it sounds like it doesn't like that I... Here it says interpret as a constant pattern, not a new variable, so it sounds like it doesn't like the collision of the names. So let's check this. Missing lifetime specifier. Lifetime. Okay, yeah, this is... No, we're getting into way too deep into stuff that I don't understand in Rust, so I don't want to... I don't want to go down that path. So let me see, does it compile at this point? It does with a warning. Okay, so yeah, there's the thing that I don't know that I'm trying to bypass is figuring out how to create a struct with like a hash that can be hashed to be used in the hash map. Ideally, the key to this cache would be both this array, the set of moves, and n. But because I don't know how to work with structures yet in Rust, I'm trying to bypass that by just keying on n and working on the assumption that set of moves is a fixed constant throughout the whole program. So that's gonna be a bit of an ugly code, and I apologize for that. It's basically I don't know Rust very well yet, so I'm gonna have to learn what I should have done, I guess, next time. So yeah, there's this like implicit dependency, I guess, encoded throughout this program in that it's making the assumption that the set of moves is constant everywhere. Maybe I can make it a bit more explicit like this. With what do I call it? Hard-coded set of moves. Then I'll just put it in here. Let set of moves equal this. Let's check if this compiles. Variable doesn't need to be mutable. Yeah, that sounds good. Okay, I think all of this is good right now. So then, okay, so the goal was to memorize this thing. So all I'm gonna do is I need another parameter here. So we pass in the cache. We also pass in n, and the idea here is we check if n is in our cache already. So how do I do that? Returns a reference to this. Some and none. Okay. Let cache result equals cache.get of n if n is a none. I don't know how to do. I probably need to look up optional. or an option is what they call it. I want you on pattern matching. Okay, so match on cache result. If it's some value, then I do one thing, and if it's none, I do something else. And I'm assuming I can do a block somewhere, right? Yeah, like this, okay. So if I have the value already, I can just return it, I think, right? If I don't have it yet, then I can compute it by calling stairs with my set of moves and with n. It's my new result, and then I'm going to stick it into the cache. Is there a put somewhere? There's no put? Come on, there's gotta be. Show me the example again. Insert key value. Yeah, okay, so insert, the key is n, the result is this thing, and then I return the result. Let's check if this compiles. Okay, so I have to borrow n again, which again I don't fully understand. Return v. Maybe I have to copy it? Use of moved value. Immutable borrow happens here. Mutable borrow happens here. Okay, I do want it to be mutable, I think. Cache result. Cache insert. Oh, did I not say I want cache mutable? I thought, yeah, no, here it is. Cache is mutable. Cannot borrow cache as mutable because it is also borrowed as immutable. It is also borrowed as immutable. Let's see. Explain E0502 to me. Explain with 2 dashes to me. This case indicates that you're trying to borrow a variable as mutable when it has already been borrowed as immutable. To fix the error, ensure you don't have any other references to the variable before trying to access it mutably. So here's the example, bad code. Y equals A. A is borrowed as immutable. A is borrowed as immutable into Y. Cannot borrow A as mutable because A is also borrowed as immutable. What? I don't understand. Show me the compile error again. Let cache results equals cache. This is an immutable borrow. Why is this an immutable borrow? How do I make it a mutable borrow? I intended for all my borrows of cache to be mutable. I'm just trying random shit now. That looked like it worked, and I don't know why it worked. Like putting the ampersand here makes it look like it worked. Try using a conversion method to vec. v to vec. Is this what they mean? Hang on, let me clear and rerun the compiler because I'm getting, can borrow cache is mutable. Here. Immutable borrow happens here. Nope, okay. So I'm gonna give up here because I think I really need to spend time reading this whole borrow concept in Rust. I don't think I can fake my way through it with the cargo culting. So unfortunately we don't have the memewise version of the algorithm, but we do have the exponential time version. And in principle, it seems like we could do a memewise version. It's just I don't understand the memory model of Rust well enough to set up. So I'll try to learn that, and then maybe I'll do a follow-up video when I learned how to do memory management and borrowing and all of those concepts work in Rust, and maybe post a follow-up video for that. But in the meantime, thanks for tuning in. Hope you guys enjoyed this programming challenge, and hopefully I'll catch you guys next time.